Hey everyone, and welcome to a super practical guide from Atop Web Technologies. Today, we are going to demystify algorithms for your next front-end interview. Let's just dive right in because honestly, this is a topic that trips up way too many brilliant developers.
And I want to start right here with this. Tech interviews can be so stressful, and that feeling of being an imposter, it's real. But I want you to remember this. You are smart enough, and you can absolutely do this. Our goal today is to give you the tools and, more importantly, the confidence to prove it.
I mean, let's just call it what it is. These interviews are tough. We spend all day building beautiful, useful things for people, but then the interview feels like it's from a totally different planet focused on all these abstract computer science ideas.
And that's the million-dollar question, right? It's not about memorizing solutions to weird abstract problems. It's about seeing algorithms for what they really are, a set of incredibly powerful tools. And in this explainer, we're going to connect those tools directly to the work you already do every single day.
All right, let's open up our developer toolbox. Our very first tool is one of the most common you'll ever need, sorting. Think about it. From e-commerce sites to social media feeds, putting data in order is absolutely fundamental to a good user experience. So let's look at our options.
So you've got three main players here. Quicksort is often the speed demon in the real world. It just divides and conquers the problem. Merge sort is your super reliable, super stable choice. It has a really consistent runtime. And then there's insertion sort. Now, it can be slower with big data sets, but for small lists or lists that are almost sorted already, it's surprisingly fast and simple. It's all about picking the right tool for the job.
Okay, let's walk through this JavaScript code for quicksort. First up, we've got our base case. If the array is empty or has just one item, hey, it's already sorted, so we just return it. Easy. Next, we grab a pivot. Here, we're just taking the last element. Then we make two empty arrays, left and right. We loop through the rest of the elements, and if an item is smaller than the pivot, it goes in the left array. If it's bigger, it goes in the right. Finally, and this is the magic part, we recursively call quicksort on both the left and right sides and then stick them back together with the pivot in the middle. It's such an elegant way to break a big problem into tiny ones.
And boom, here's a perfect real-world scenario. You're sorting thousands of products by price. The user clicks that button, and they expect it to be instant. Choosing an efficient algorithm like quicksort is what makes the difference between a UI that feels snappy and one that feels sluggish and frustrating.
Okay, so once your data's all nice and sorted, you're probably going to need to find something in it. And that brings us to our second tool, finding data fast.
Let's talk about binary search. The number one thing, the big catch you have to remember is that it only works on sorted data. But if your list is sorted, oh, it's unbelievably fast. Instead of looking at every single item, it just keeps cutting the search area in half. That's what we call logarithmic time complexity, or O log n, and it is ridiculously efficient for large lists.
And the code for it is just beautiful. We set up 2 pointers, low at the start of the array and high at the end. Then, as long as low hasn't passed high, we keep going. We find the exact middle point. If the element there is our target, awesome, we found it. If our guess is too low, we know the answer has to be in the top half, so we just move our low pointer up. Otherwise, it must be in the bottom half, so we move our high pointer down. We just keep slicing the problem in half until we find our answer.
And you have totally seen this in action. You know when you start typing in a search bar and it instantly gives you suggestions from a massive list? That's the magic of binary search. It's not scanning everything from A to Z, it's intelligently jumping right to the section where your result is likely to be. It makes the UI feel so responsive.
All right, as front-end developers, our world is the DOM, the document object model. And what is the DOM really? It's a giant tree. So our next couple of tools are all about how we can move through these tree-like structures efficiently. So we've got 2 main strategies here. There's depth-first search, or DFS, which dives all the way down one branch as deep as it can go before it comes back up. This is great when you need to visit every single node in the tree. Then you have breadth-first search, or BFS. This one explores the tree level by level, and this makes it perfect for finding the shortest path or the closest node to where you started. So to make BFS work, we use something called a queue. You can just think of it as a waiting line. First in, first out. As you can see in the code, we start the queue with our root node. Then, as long as that line isn't empty, we take the first node out of the line. We do whatever we need to do with it, maybe just log its value, and then we check if it has any children. If it does, we add each of those children to the end of the line. This simple process makes sure we explore the entire tree one level at a time.
This is such a great practical example. Imagine you're building one of those sticky tables of contents that highlights which section you're on as you scroll. You need to find the nearest header element above you.
BFS is the perfect tool because it explores outwards, layer by layer, which guarantees the very first match it finds is also the closest one.
Now, tied really closely to navigating trees is recursion, which is just a fancy way of saying a function that calls itself. I know it can sound a little intimidating, but it's such a natural way to work with nested things like the DOM. You just need two things: a base case, which is basically the off switch to stop it from running forever, and the recursive step, where it calls itself to solve a smaller piece of the same problem.
And here is where recursion just shines in UI development. How do you render a sidebar menu that has categories and subcategories and sub-subcategories? A recursive function is the perfect answer. It renders one level, and then for any item that has its own children, it just calls itself to render that submenu. It's clean, it's simple, and it's incredibly powerful.
Okay, we've covered a bunch of tools. But here's the real secret, the skill that's going to make you stand out in that interview. It isn't just knowing what these tools are. It's knowing why you're picking one instead of another.
And this right here is the language we use to talk about performance, big O notation. It's just a way to describe how an algorithm's speed changes as your data gets bigger. Knowing that a binary search is O of log n, which is super fast, while a good sort is O of n log n, lets you actually justify your decisions. And for tree traversal, O of v plus e just means the time it takes depends on the number of nodes and connections. You pretty much have to visit everything once. So all of this comes together in a simple three-step strategy for your interview. Step 1, look at the problem and pick the right tool for the job. Step 2, and this is the most important part, state the trade-offs out loud. Actually say, I'm going to use merge sort here because I need a stable sort, even though quick sort might be faster. Then, and only then, do you start to code.
This is the #1 thing to take away from all this. The interview isn't a memorization quiz, it's a test of how you think. They want to see your problem-solving process. When you follow this strategy, you're showing them that you're not just a coder, you're an engineer who thinks clearly and makes deliberate choices.
So I'm going to leave you with this question. Instead of going into that room asking yourself, do I know the answer? What if you went in asking, what's the best tool for this job? Shifting your mindset from fear to curiosity is the entire game. If you found this helpful, subscribe to Atop Web Technologies for more guides just like this. You've got this.